Welcome everyone to the 11th Chinese Knowledge Seekers Workshop, brought to you by the Keshe Foundation Spaceship Institute. And today we'll have Marko will be our featured guest in today's workshop, and he'll be directing it. And we'll be hearing from the Chinese Knowledge Seekers. First, we'll have the promo video for the Keshe Foundation Spaceship Institute with Chinese subtitles. Go ahead, Vince.
欢迎大家开始我们第11次中文网
Where
教
does
学
humanity go from here?
开始进行
What have we tried to do? What if there is more? Much more. The Keshe Foundation is proud to announce a new way to bring humanity forward through technology that brings humanity in line with the natural operation of the planet and universe itself. The new science and technology discovered and developed by the nuclear engineer Marko Keshe centers upon the use and control of magnetical gravitational fields. This new body of knowledge opens the road to hundreds of potential applications, which offer solutions to most of the fundamental problems of the world, such as water, food, environmental contamination, and shortages of energy. The Keshe Foundation is proud to unveil the Keshe Foundation Spaceship Institute. Nestled amidst the beautiful shores of Bari, Italy, the Institute is poised to become a central hub in the spreading of plasma technology and knowledge. With its state-of-the-art 21st century facilities, the Institute will be able to provide students and staff an immersive way to learn the plasma technology, to be the leaders of the new generation of scientists and plasma engineers. The Keshe Foundation has opened the door to the world for peaceful usage of technology that is independent of the limited resources that are available on Earth. This is an understanding of how everything works together in harmony in our universe, and it applies to everything from the smallest to the biggest, from atoms to galaxies. We all are able to collectively work together in pursuit of knowledge, innovation, and solutions for our society. This learning environment is new to the world, where there will be no test to confirm your understanding. The knowledge of everyone will be respected and allowed to flourish in a nurturing environment. Hands-on testing and experimenting will be widely used in conjunction with roundtable discussions to bring all opinions and knowledge forward. Students will be introduced to a change in the ethos of working in collaboration. Students will experience firsthand how we share knowledge in a free and open manner. Graduating students are expected to share the knowledge they gain from the university within their respective communities and nations. All formal teachings, lectures, and presentations will be in the English language, with technology available for immediate translation. Keshe Foundation Spaceship Institute will be offering 3-year executive master programs for undergraduate degree students and 1-year executive master programs for graduate degree students in the following fields: space transportation, new plasma technology, health, agriculture, materials, energy. The health section is designed to make students able to live in space without the need to return to Earth. To this end, the Keshe Foundation Spaceship Institute has found processes for many diseases including ALS, cancer, coma, epilepsy, multiple sclerosis. Keshe Foundation Spaceship Institute will offer online teaching courses which will enable anyone, anywhere around the world to enroll and increase their knowledge and understanding. Students will have the opportunity to direct their work towards commercial spin-offs and seek funding through the help of the Keshe Foundation. The access to the new science and new technologies is openly available for peaceful use to the benefit of mankind to make a better world today. Now you can be part of the changing world and the new knowledge. All commercial spin-offs are intended to be open source and patent-free. This is part of the core ethos of the Keshe Foundation and the Keshe Foundation Spaceship Institute. Keshe Foundation Spaceship Institute will have its official inauguration on April 21st, 2015, with courses commencing soon after on May 4th, 2015. The students of the Keshe Foundation Spaceship Institute will be the leaders of the future who will make changes in all areas of space technology, science, medicine, agriculture, and energy. Anyone is able to apply, but acceptance is through invitation only. No prerequisites are required. We will be accepting approximately 250 students for the 3-year Executive Master's Program and 120 students for the 1-year Executive Master's Program. We welcome humanity's participation in the knowledge of the Keshe Foundation Spaceship Institute. Where does humanity go from here? That is up to you. Apply today.
Oh, hello.
Okay, that was the promo video. I'm just getting my screen set up here so we have a screen to look at. Get the questions set up. Are you there, Marko?
Yeah, I'm here. Good day or good evening to our Chinese friends in this workshop. Today, Mr. Keshe is not with us because he's away in some other presentation on university nearby, and maybe he will be able from time to time to join us in this session. So I will try to answer you in my way, in my understanding, what I can, from my point of view, what I can help to Chinese knowledge seekers. So maybe for the beginning, I can just tell that this cancer trial is also beginning in next month or next weeks. So people who are interested to participate in the cancer trial case with use of new technology, they can apply and send email to cancer@spaceshipinstitute.org. So also Chinese people are welcome to this project. If there are doctors who would like to monitor these cancer patients, they can also send email to doctors@spaceshipinstitute.org. So maybe I can try to write on the board.
I need to translate.
Okay, this I got.
今天是就是因为开始先生在给其他的大学可能就是有讲座，所以呢开始先生就是不在，也许他会连接到我们，也许就是不在。然后呢，今天由我来给大家就是做这个教学，大家知道 Marko 了，这是 Marko，然后呢，我们在近期会进行的这个癌症的这个等于是叫类似于实验治疗吧，然后虽有就说疾病想参加这个志愿者，那么可以到这个就是 cancer@spaceshipinstitute.org， 然后如果有医生的话想参加这个就是我们这个节目的话呢，可以给寄信到 doctor@spaceinstitute.org。 Okay, go ahead, Marko.
Second thing that I would like to say, it's also that our master student study program was started and on 4th of May, and it's 1-year program. But this program is available also online. So people who are not here in Italy, they can join us online in this teaching session. And even if they join us later, they have access to all the teachings. All the recordings are available on the server, and they can listen them whenever they want later. And so whoever is joining us can listen later and have ability to catch up with all these teachings during this teaching. So everybody can choose his speed of progress in learning.
我们 translate。第二个事情的话是说，我们这个就是1年制的这个硕士学位这个就是这个程序大家呢可以就是原来是不是说5月份申请可以到意大利吗？如果你要是不能来意大利的话，你随时也可以申请我们的在线教学虽然是从5月份开始的，但是我们的这个所有的教学我们都有这个就是录像你可以就是说都可以查到，可以就是说得到。所以呢希望呢如果是大家想学习的话呢，随时都是可以报名的，我们这个是一直在接受当中。
So also Chinese students are welcome in this teaching program.
然后也非常欢迎我们中国朋友参加。
Okay, now I think also you prepared some questions, or maybe you can just also your experiment that you are doing in China, and let's go to the question.
然后现在的话就是说
Can I speak?
Sure. Mr. Keshe.
Yes, sorry. Yes, I just have a few minutes to add. Thank you very much for carrying on with the workshop. It's an important announcement for Chinese and other scientists and the people who work around the work of the Keshe Foundation. The Arman is in China with Sohail, and they are setting up the laboratory of the Keshe Foundation in China. And we need scientists or people who've been developing different aspects of the foundation's work, who would like to get it commercialized and work on a full-time basis for the foundation in China. So if you're a Chinese knowledge seekers or a Chinese who's been following different works of the foundation to do with CO2, energy, and others, please contact Sohail at the address which will be given is where you can buy the products, and contact them that you can join, and then they'll most probably interview you. And it's the first cycle of scientists which now and the researchers we accept for development and commercialization of different aspects of the technology. So if you're a knowledge seeker and you have a good understanding of the technology and you can see to convert it into different applications, please contact the the Keshe Foundation in China. There is a job opportunity for a number of people who they decide as they interview. This be it for the use of the Gans, be it for the use of the different materials and production of the star formation systems. If you want to translate.
Yeah. 开始先生说，说正好我可以进来。现在，那么我给大家一个宣布一件知识，宣布一个就是说信息，关于我们中国的这个就是说有关的我现在知道阿门跟那个Sohail现在在中国在建立我们的这个建立一个实验室。 所以说如果任何一直在就是说跟踪我们的工作的人，还有中国的知识寻求者，还有或者你就说是各方面的科学家，或者都可以呢申请我们这个，就是我们现在有工作位置可以申请，就是全日为就是一个 full time job 给这个开始基金会。所以呢，如果你要是一直比如说在能源方面呢，二氧化碳干细胞还有其他的就是说各方面的应用，如果想参加进来的话，可以跟索海尔联系。OK。
Thank you very much. I'm going to mute and drop off. Carry on with your presentation. Thank you very much.
Thank you, Mr. Cash. 开始先生说那么你们现在可以继续进行你们教学了。那我现在把我的这个说话关掉，然后我说谢谢开始先生。So now we start the questions, Marko.
Yeah. Just I don't know. Are you going to read them in Chinese first, or who will read the question?
Okay, so we can have Rujun, you read in Chinese, and then.
好的，能听到吗？
能。
OK， 那么我们首先呢是进入到本次教学的第一个问题，是由这个郭鑫2235这位朋友提出的，是关于活力生平的。那么他其中的第一个小问题是，这个图片里面是一个朋友做的这个活力生平，那么我们可以去仔细看清楚它的结构那么其中磁铁和干丝之间是隔离开的，并没有接触。用自来水烧开的水倒进去以后凉一凉，几分钟就喝了。那么磁化的水呢会有点发甜，嘴里面会长时间的感觉到有甜的这个味道，感觉呢人比较有精神，然后春困的这种感觉没了，始终都有这种甜的感觉。那么就请问Marko，这样呢是否正确？就是这样使用活力生平的方法是否正确？为什么喝了那个水以后嘴巴会有甜的味道，然后春困的感觉也没有了
？Okay, the question is in here. You can see in the following pictures, one of the Chinese knowledge thinkers had made a cup to supply energy for body. The structure of the cup is like this in the left picture. Has a magnet, Gans. They are in one small container. It's like the whale in the middle picture, and then put in the big cup. The big cup has a nano. I think it's a nano. Yeah, and when people use it, it is fully in water and then drink the water. The question in here is that he drink the water and it felt a little bit sweet, and he felt more energetic and more alert than before. It's not feel like so like tired or sleepy. So his question is why he has the sweet taste, and how come it's so energized, and has any problem or what?
So, sweet taste depends what kind of Gans he has put inside. As I understood, he has put different Gans in the center of this cup, and there is nanolayer on the outer edges. Is that right, or is this double wall cup, so that he has put Gans in the double wall.
Marko 回答说你这个甜的味道是因为可能跟你放里边的干丝的种类有关。
Is he using also the magnet like iron magnet or?
I don't know. I need to ask. 知道这个磁铁是什么磁铁吗 ？Marko 问说这个磁铁是什么磁铁？有人可以打文字在这里边，或者打文字给。
往后看一下，看他有没有写。
So why sweet? Sweet is
Could you adjust the microphone a little bit, Marko?
Yeah.
Okay. I have a question to ask, because now in China they have some people, they are making those cups, and like they think it's according to Keshe technology. So I don't know, what do you think about those cups? Because they just sometimes they have nanomaterials in the like a double layer in the center. Or sometimes they have Gans and the magnet. So what do you think about those?
Can I make a comment here, please? We have seen people using the logo of the Keshe Foundation or a Spaceship Institute on these cups. These are illegal. And secondly, we do not support any kind of consumption of water or what do you call it, containers of food which are built or made by Gans just because we have brought the technology out. This has to be checked, has to be organized, and then approved by us and international organizations. So anybody who's producing these cups, what they feel and how it is at their own risk, and we do not endorse and support it. And we ask people, I already had a case, came to me from China, we ask you to withdraw the logo of the Keshe Foundation and the Spaceship Institute from your documents and your papers and your cups. And if we see this, we'll make a complaint to server holders and they block your server. We will take these actions. This is very serious abuse of a registered name. Okay? We do not make a comment because somebody else can drink the same water and have a different problem. So we know people are doing this, but we are not supporting it, and we're staying out of this discussion. We have to be correct by law. Okay?
Okay.
Thank you very much.
Okay. 那个石头你翻译一下，我刚才没太听清。就是我先说前面部分吧，我先说前面部分。
刚才我们
开始先生说首先呢，我们就是说对这个呢，就是说我们看到有人可能就是卖这个杯子，把我们开始基金会或者把太空学院的这个 logo 放在上边首先我要说这个是不合法的然后另外呢，我们是不支持这种就是说独自怎么说呢，就是没有经过我们技术支持的这种产品。然后下面你说吧。
就是现在这个活力圣瓶，因为 开始基金会目前是不支持或者说不提倡大家自己去尝试去引用或者是使用，因为呢这个必须要经过这个组织和安排，也要经过开始基金会的认可，还要经过国际组织的一个认证，这样的才能作为一个产品。而且呢开始基金会呢对于刚才说的就是有国内的这个网友呢把这个太空学院还有这个开始基金会的这标志呢用在了产品上，这是非法的一个行为，因为那么我们已经建议这个国内的这个生产者呢，已经把这个所有的标志跟太空学院有关的标志和开始基金会有关的标志全部都已经删除。如果说还有这样的行为呢，基金会是保持一个采取相应行动的一个权利，那么还是要郑重的告诉大家，就是这样一个涉及到就是这是一个比较慎重的事情，必须要有一个正规的一个程序来进行。OK, Lisa.
Okay. So we have the second question.
好的。
We can ask Rujun to read the second question in Chinese.
好的，那我先念一下，这个还是同一个郭鑫的第二个问题。这个问题呢是关于干式电池的。如图呢，这是一个干式电池，它的长度是1厘米，使用了纳米铜、吸水纸、二氧化碳干丝、氧化铜盒子周围产生的纯盐干丝，然后呢用镁和铝箔包裹它们，再用铜线将它们缠紧，得到了2.1伏的电压，和200毫安左右的电流，没有任何的密封。那么对这个实验提出的问题是，我使用了2个这样的一个单元，就是2个这样的一个装置串联起来，得到了4伏左右的电压，可以点亮一个3伏的 LED 灯。但是从亮度上，我们知道200毫安的电流点亮 LED 灯是不可能只有那么微弱的。电流表上还显示为 HV 高压，那推测是不是电压表出现了异常，或者说电压表在周围有干丝或者纳米材料的情况下被它的性能或者它的功能被影响。那1周后呢，这个装置还是干燥了，这个电池干燥了，电压降低为原来的1半，电流表测试没有变，但是 LED 还是正常亮着。请问如何保持电池内部的湿润？还是说使用干丝制作一些发电小元件，其实可以不用保持湿润就可以永久发电？ Lisa.
Yeah. The question is on the bottom picture. It shows we did a battery device, and it's about 1 centimeter long, and at the beginning the output voltage was 2.1 volt, and the current was about 200 milliamps. He shows, okay, had explaining how he did load these batteries. He used put a nano-coated copper wire and CO2 gas and CuO gas and a little a piece of paper, and he wrapped up, use magnesium and aluminum foil, and then tightly, let me see. Yeah. And the question is, he said he used 2 of them, can get 3 volt and can light a LED, and but even he measured 200 milliamps, but still not bright enough. So it should be a much brighter, but it's lighted. Then he asked one to could you please explain the reason why it's not so bright? And also he said after a week, its output like become down to 2 volt. The current is still the same, but and also the light is still on. So the question is how to prevent it from dryness, and whether it's okay. So just use a dry Gans. Do you understand the question?
Yeah, well, we have done similar experiments a few months ago, I think in the September, October last year, and we showed these batteries, Gans batteries, also in our public workshops. So we used similar process, Gans and nanomaterials. It's very difficult to say how exactly you want to keep your how to prevent dryness. You have to find a way, but most important to me is that you understand what you are doing. How did you put together all these Gans cells? If you are using Gans material, you can use it like a source of energy, and in combination with nanomaterial, you can achieve plasmatic flow. But if you want to use it with with devices, with electronic devices, you have to convert this plasmatic field flow to flow of the energy in electron level. So you have to find this conversion somewhere between your nanolayers and your method. You have to remember that nanolayers are like plasma environment, and they're superconductors. So the current in nanolayers is in plasmatic form, not in electron level. So in a way, you have to slow down or make your relief also.
There's some noise.
No, it's near another microphone, most probably.
I can translate.
Okay.
Marko 解释说我们以前在这个教学当中就说给展示过解释过这些个电池他说呢你用这个干丝材料和这个纳米层材料，实际上是干丝的话可以释放所有的你的这个所需要的能源，但是呢你的问题是说你要知道你这种组合的原理是什么，你要知道如何能把这种能量转化出去，因为这个纳米层的话，用纳米材料的话，纳米层也是就是说这里边的能量是在这个磁引力场的这个形式下的，但是你要是想把它变成直接的这个电流电源的话，你需要把它降低到电流的这个层 次，所以你就是说要考虑这种转换方式怎么样把它给降下来。
So maybe Mr. Keshe can add something if he's still online. Sorry?
Oh, he's not.
He's not.
然后Marko 再问一下，说是不是开始也可以回答一下，然后说开始不在线。
You have to see also what is happening inside your Gans cells. You have to see if there is also any matter interaction. If you're losing your voltage, try to see that. Try to work only, let's say, try to separate working in the plasma level from the matter level, so that you all the time that you understand when you have flow in plasmatic magnetic field strength level and when you have flow in electron level, and when to do this conversion, because when you are using your LED works in electron vibration level, so you have to convert your plasmatic flow to electron vibration level. Otherwise, you will not have any results. But in a way, with Gans and with nanomaterial, you have much stronger flow of fields, which cannot be used with the equipment that we are using in electronics. So you need to do this conversion somehow. You have to find out how to break down these strong fields to the electron level fields. If you understand, if you have nanowire are let's say atoms separated layer by layer. And this nanolayer is superconductor. So in this direction, superconductivity because you have magnetic environment inside, and the field strength in these layers is much stronger than electron vibration level. And so if you use another Gans or connect two Ganses, you have flow, but somewhere in this flow you have to break it and bring it to electron level vibration, so that you can use this field flow with current devices. Okay, let's go ahead.
OK，Marko 解释说，你的这个电池的话，就说，这个干式电池的电压下降的话，你要考虑到里边是不是有这种，和物质的这个相互作用，然后引起的，同时呢，他说你还是要看一下这个，就说，从磁力引力场的这个。在高的这个能级的这个，就是说你要对这个就是我们电流的这个磁场的这个能级的这个转化，你还是要就是说知道这个转化和这个流动。然后他现在画了一个图，他说这是纳米涂层。那么纳米涂层呢，里边是就说有一些个这些层跟就说 纳米材料这个之间呢，这个纳米粒子的中间呢会有一些个层，这些层呢会有这个 就是场的这个流动，然后你两边呢，如果放着干丝的话，两边场会中间流动，所以你要从中间呢，你要是取出来的话，你要给它能够进行转化。他说你还是要找到这个转换的办法这样呢你才能就是说，因为你要用在这个电子的这个这个级别的这个场，所以你必须要会转化。
Is the person online or
有没有在线？他们在线吗？也不没在线，没在线。那么我们就下一个问题吗？
要不我再补充2句吧。好的，那个刚才 Marko 解释说，实际上有个关键问题，就是说我们测到了这个电流电压因为它是来自于纳米层的，纳米层的水平方向呢是超导的状态。那么里面呢，如果在刚才画的那个图中两侧放上这个干丝的话，那么就会有这些油干之间的这些磁场流，在这个纳米层的超导层面发生这个流动。那么现在关键的问题呢，就是你要想办法去把这些纳米层面中的这些磁场流，因为这个磁场流的强度呢是比这个我们所说的这个电子的这个强度要高的，所以你要想办法要把这个磁场流呢给利用起来，把它这个强度降低到这个电子强度的这么一个水平，这样呢才能够用通过这个装置呢，发电装置呢，去产生这个比较理想的一个电流，才能够去带动这个 LED 的这个灯，因为 LED 用的是电子振荡的这个强度的，所以呢，最关键的问题还是要学会怎么样把这些磁场流，这些源源不断的磁场流给转化成这个电子的强度，才能够利用起来。Lisa。
Okay. So, next question.
Okay.
Are you still want to explain more? Marko?
I don't know. It's this clear enough, or is there any sub questions regarding that?
And Marko, do you have any suggestions, like to think the way to do the conversion? Because people now seems to get stuck here.
They are stuck here. Okay.
Yeah.
There are people who are much more have much more experience than me in this field. So I can not give you like a quick recipe, but what you can do. If you have these nano layers here, you can try to break them. I don't know, try to, in certain point, try to squeeze these nano layers. And when you squeeze them, the field flow in these layers is not so easy anymore, and it has more friction. So this friction release fields that are in electron level, and then you can absorb them. So I would suggest to you, try to use your fingers and different type of nano coatings, and use different pressure on these nano layers, and then test these nano coated wires, and see which wire will give you most of the results. That's my suggestion to you.
Okay. 我刚才我问了一下 Marko 这个问题，我说，那么怎么样我们才能促进这个转换呢？我觉得好像大家是不是都在卡在这里了？然后 Marko 回答说，你可以试图，我可以给你一个，就是说一个建议，我也没有完全的这个菜单，就是说，我可以给你个建议，你可以呢对这个纳米涂层呢进行挤压，因为这一挤压的话呢，这个磁场会出来这个碎片，你可能会收集到更多的这个就是电子的层次的这个磁引力场。你也可以试不同的这个纳米材料，这个纳米涂层。然后下一个问题，
好的，
磁引力场。
那么
你也可以。
下一个问题吗？
对，第3个问题。
好的。
The third question.
OK， 还是来自郭鑫的这个问题。那么第3个问题呢是这样的：纳米涂层镀锌铁加纯铜线，以十字形对立摆放在一次性杯子里，加入盐水，经过2天出现比 CH3 更红的干丝，表面还有类似油脂的物质。由于铁和铜都是人体中有的主要物质成分，那么是不是可以推测这种干丝跟血有关系？请问这种干丝是什么干丝？可以有什么样的作用？
Yeah. Can you read the questions, Marko? It's that it's I don't know. It's a zinc coated iron wire, and another one is a copper wire. He said he put them in a plastic cup. I don't know. He said a cross put in there. I don't know. It cannot say it. It's like one is one direction and another is another direction. So he put salt water in, and after 2 days there's some Gans. Got some Gans, and it's much brighter. It's much brighter Gans. It is compared to CH3. So he's saying that since iron and the copper are all the minerals in human body, so does this Gans something related to blood, or what kind of Gans of this, and what are the usage?
Yes, this Gans is related to blood.
Related to blood.
Creation of blood. In our online teachings, Mr. Keshe several times showed blood in the containers that we have here. It's a similar color. I don't know if we can show in our containers, maybe just in the bottom there is this red color.
Okay, you can see it. Yeah.
So we are producing same things here, and Mladen, another knowledge seeker here, he produced same material, same Gans at his home, and even today in the morning session, we talked about this. So what is happening there? Would you like to translate, Lisa?
Yeah,是，Marko 说，这个呢应该是跟这个血液有关的。他说我们前几次教学里边也都提到过这个问题，在上午的这个教学我们还说了这个问题，说大家可以看到刚才那个盒子里边那个底下是红颜色的。
Okay, what's happened over there? Most probably you absorb different GANs, CO2 GANs, and you created also a layer of fat on the top, and then iron was added, and inside your cell you created GANs of iron, which then connected to this amino acid. So the link was created between amino acid and iron. So you created this condition of blood cell. If you know, our blood is a combination of amino acid. What we call amino acid is NOCH, and this is in plasma state. It's a Gans state of amino acid. So when you have this plasma and you have iron Gans, and when you create connection between these two, you create new plasma, which is actually this blood, red blood cell. But here in your cells, it's different than in the human body. In this morning session, we talked about properties of blood. When blood is inside our body, because it's in vacuum environment, it behaves completely different than when it's outside. So also environment that blood is in decides the properties of this element. So here again, there are a lot of applications of this material, but this should be done under control and inside a scientific institution with all the measurements. This material has a lot of application, but as I said, it should be monitored very strictly, and you're working with this, you have to understand what you are doing.
OK，Marko 解释说，说这个呢，因为你是放的这个铜跟这个镀锌的这个铁在这里边，一开始的话呢，它会生产出一些个，比如说二氧化碳干丝或者还有一点氨基酸然后呢，你这个铁如果参加进来的话，就说铁的干丝，这个呢是形成了这种。就是这个氨基酸会有含铁，是跟这个血液的这个细胞的里边的这个成分就比较接近，所以是红颜色的。但是呢，因为这个是在就是因为这个血液细胞在人体内和在外边是不一样的所以呢它会表现出性质结构都不一样。另外提一点就是，这个东西呢，虽然可能会有很多用途，但是呢，不建议，就是说，就说建议大家呢，应该是在这个，就是说比较正规的机构，然后在这个科学指导下，然后使用这些个材料来应用，就是不要就是意思不要随便用。石头还有其他的补充吗？
没有了。没有了。
好吧。 那 Marko?
Yes. So, what can you do with these guns? Yeah, you can do. I would not like to propose you anything at this moment. I think specialized laboratories should do more exam on this, and then you can use it in your life. So I think people who are more interesting to look more in depth into this understanding, they can join us on online teachings where Mr. Keshe is going more in depth in this technology, and he explains more about these materials and how can be used. So I'd rather not say anything that so that you don't use it in the wrong way.
Marko 解释说这个东西是会有很多用处，但是我现在不太想说就说给大家提任何建议，因为这个东西还是要就说我们还是要小心，而且希望能够就是在这些方面有比较深入研究的科技人员参加进我们这里，然后可以一起探讨这个这方面的应用，也许那个时候开始会进一步的给我们指导。目前的话呢，说不希望就是说给提任何建议，然后会使大家有一些个就是说实验随便就是不小心。So question number 4。
好的。那么第4个问题呢是这样的，我们做的这个二氧化碳干丝套包中产生的氧化锌，还有这个干丝包中产生的氧化亚铜，这些是不是和二氧化碳干丝一样都是干丝肽呢
？Okay, the question number 4 is we get the zinc oxide when we produce CO2 gas, and also Cu2O when we produce CuO gas. My question is whether the zinc oxide or the Cu2O are in the same state in the state of Gans. Are they Gans?
How you produce it depends on the process how you produce it. But as according to the question, if you are using in salt water, you still have Gans state of these materials.
Marko 回答说，这个是看你这个生产的这个过程是如何的。如果你用这个二氧化碳干丝包的话，也许会会有干丝状态。Yesterday in the teaching, Mr. Keshe said, when you have the zinc oxide, you may have like a normal matter particles of zinc oxide. You can have gas zinc oxide, and you have different. It's like a mixture.
Yes, as I remember in one of the teachings, Mr. Keshe explained that when you create this condition of conductivity inside your cells, that if your plates or your wires are more touching the bottom of the container, and when the Gans is is settled down in the bottom, and it creates conductivity. You get also zinc Gans, and you can see that the color of these Gans is different than CO2 Gans.
然后 Marko 解释说，开始也提到说，如果你要是
workshops, Mr. Keshe explained this. Go ahead, Lisa.
OK， 然后说你可能会有，就说你的条件不同，可能会有不同的东西产生，而且如果你要是这个你的这个电极板子如果要是在下部接触到 CO2 gas 的话，那么有可能呢，就还会产生就是新的干丝或者其他的干丝。能补充吗，石头？
没有，我后面没听清。
Okay, so are we ready for the video for the second one? Rick?
We are ready here.
So if not, we go to the question number 3.
I don't have a video. No, I don't know where the video is supposed to be.
Can anybody else show the video and share his screen, or?
This video is about the CO2 gas produced by Omega Quantum, and they did some alkaline and acid test. So they put some acid. I think it's
Yeah, can someone show the video so that we can actually see it?
Video 那个小何，你能展示吗？你那里，要不然给你桌面，你展示。
Like if we can make, if someone can show it on QQ, if it shows up for someone, then we can make you a presenter and you can actually show it on the GoToWebinar.
如果你们谁可以是能展示这个视频的话，可以把你变成这个展示者、演示者，你就可以在这个视频上展示。
我正在从那个小何那边接收这个视频，还需要半分钟。
你怎么还在接收啊？哦，小何不可以吗？小何可以做展示吗？
还需要20秒钟。
I still need to another half minute. Okay, so let's go to the third question.
Lisa, do you have this video on your computer?
I cannot. I don't have it on my computer.
So if anybody else has it on his computer and he's inside webinar, he can share his screen.
I'll share the.
Now I'm ready.
Okay, you're ready. Okay, Ruji is ready, so maybe he can show it. 你知道怎么展示吗？Do you know how to?
Let me try. I will try.
Okay. Okay.
Wait a minute.
Okay.
Waiting to view screen.
你用哪个？用展示我的桌面。
Just a minute.
We cannot see anything here on our side.
Yeah, Can you see?
I don't have his window.
Can you
Do you
see
know how
now?
to use it? 你知道怎么用吗？你会吗？要不要问他们？
Show my screen. You can press show my screen.
Is it?
Yeah.
Okay.
Is it? You see that? Okay.
I cannot.
I see a CO2 kit. You have to select.
I play the video.
Okay. Okay. Now, yeah.
Okay. Let's see.
So the
Sorry.
video. You can read the like subtitles in English here. So 你可以念吗？也许可以念
我不能动，因为它两个窗口不能站在一起，要不然就停了。
那行，那我可以念。就说这是一个就说用这个二氧化碳包得到的二氧化碳干丝。This is the CO2 captured by the CO2 kit. And now she is cutting a bag of vinegar. 是把这个就说一个醋给剪开，然后放里边。然后现在呢，就是给它要搅拌一下。He put the vinegar in the cup. It's a beaker. Now you can see it's gradually like seems to disappear. 就是你就逐步它就透明了。然后呢，他现在又放那个 baking soda， 然后现在放碳酸氢钠小苏打。把这个放在水里，然后让它溶解，然后把它倒进去。First he dissolved the baking soda to water. 这个展示很不连贯，很不清楚。Now she is pouring the baking soda solution to the Gans. 然后现在把这个苏打水往这个里边倒，刚才的这个被酸溶解掉这个 Gans 里边倒，然后现在呢，我们看到有东西出来。Now we can see the first there's a lot of bubbles come out, and then gradually can see the precipitations. And then like he let it rest for half hour, and it shows a layer of oily material on the top. And now he putting another, add more sodium bicarbonate solution into it. 现在他把就是再放了一部分，这个小苏打溶液，然后现在看到可以就出现跟浆糊的东西了，就比较 ，it's look like jelly。And then let's settle for another half an hour. And then I think she let her settle for 3 days, like 70 hours. And then now she shows the comparison between and after. Mm. 它们像一块一块的 ，it look like a big chunks of them falling down. It's like when I'm making CO2 Gans, I didn't move the container for like more than half month or so, and it's turned to like a jelly on the plate. This one looks like that. It's like jelly or glue.
When Gans compacted itself, it becomes more like jelly.
Yeah.
Water is squeezed out from the space between Gans, and then it becomes more compacted, and you can observe that if you have it in a container, it shrinks, and but you still have a little bit of water between these Gans. More compact. What is this now? Second.
This one, you mean the showing now? The show is one is a before, and the other is after. So they compare the quantity. So it seems like she says the quantity become less.
And what happened when she added vinegar at the first?
It becomes all transparent.
Transparent. Anything? She cannot observe anything in the bottom of the container because there are some reports that when you add vinegar or special kind of acid to this to Gans, Gans changes to nanolayer again. I think Emmanuel has done this experiment, and he observed on the bottom of the container these small black particles. That's why my question is, does she observe this also when she is using vinegar? Because vinegar is an acid.
So you mean they become more compact? It seems like nothing there. It was like all clear.
When you add something in, you change the environment, and Gans respond to this environment. So when you change it, it can open up or it can shrink. When you show this, it's completely transparent, or did I?
I'm not sure. When I do like experiment like those, I do see small particles in the liquid. I can tell they're different. They are not the water.
Okay,
they are not one totally dissolved, but I can see them, but they don't.
If this can be confirmed, you can see small particles in the liquid. That's important thing, because from last Thursday workshop, you were looking what kind of substance or what kind of magnetic separation we can use to achieve separation of the Gans inside our dynamic reactors. So if we are able to change Gans to nanostructure again and use these nanomaterials as separation, or to have it like magnetic properties for separation of Gans inside dynamic reactors, this experiment could be very useful.
OK， Marko 解释说，他说你加入酸以后呢，会使这个环境呢发生改变，就说尤其是后来这一系列的反应，那么会使这个干丝呢成为纳米材料，中间就说会有纳米材料形成。然后他说加入醋酸以后呢，底下能不能看见一层颗粒？我说好像似乎看不见。然后Marko 接着说是每次呢你会改变这个环境，这样的话它就会你就改变了它的这个结构就变成纳米。然后石头你再翻译一下。能吗？
他们说要请注意观察一下这个加入这个环境变化以后，下面有没有新增的这些颗粒物，它的颜色可能会暗一些。然后呢，这一些就是他们从这个干湿状态，因为环境改变了，又重新恢复到了原来这种纳米涂层的这种颗粒的状态。然后反正因为这里也看不到这个到底有没有描述到这个方面。
I can see something black in one of the containers, so it would be very interesting to see more details about this experiment. Can we get more details? What exactly she observed when that lower right corner of the picture? You can see black particles, and this shows like indication that you change part of the Gans to the nanostructure again. So this can be used then for certain applications also.
OK， Marko 姐说你这里边可能会有一些个这个固体的物质会产生。他说呢，你看这个右下边的这个下边会有着黑的这个就是黑色的粒子。就说这个一般是纳米材料，这个会有很多用途。
So what she's doing when she added vinegar, it changed to sorry.
Okay, go ahead.
When she added vinegar, she changed the environment of the Gans. And let's say if vinegar introduced more gravitational fields environment, change the environment of the Gans, and this Gans shrinks. And the opposite, if you add the baking soda, you have other part. You increase again magnetical, and you get balanced environment again. So you get first solution with some residual on the top. So that's how I see this experiment.
然后Marko 姐说你第一次加入酸以后那么你就说改变了它的磁引力场环境，所以呢会使它就说有改变，但是我没听清啊，就说是状态改变还是就是形态改变。然后呢，等你再加入碱以后呢，它又回到了就是原来的这个状态，可能就说又回来了，所以就说又展示出来。石头，你能翻译一下吗？或者补充？
我只能是我的理解，因为他说了这个酸和碱的环境可以造成这个整个环境的变化嘛，然后意思就是说，在弱酸的环境下，它原来这个水给这个纳米材料提供了一个显化的一个环境，但是因为酸性以后呢，它就隐藏了起来，或者说它通过这种转化变成了原来这种纳米涂层的一个状态，那么大家都看不到。然后加入碱以后，使得这个环境恢复到原来的中和的状态，然后这个水的环境又可以提供一个显化干湿的一个作用，然后呢，就使得这个干湿又出现恢复。但是其中发生转变了之后的干湿，就是变成纳米材料的干湿呢，它就会变成像刚才说的，就是下面有一些沉淀物，或者说是比较颜色比较暗的颗粒。Lisa。
Okay. About the second question, it says, okay, you are explain more, Marko?
No, maybe just if we can get more details about what kind of vinegar she's using, what percentage of vinegar, so that we can get better insights and so we can do more research in this case. How to achieve this conversion of the Gans material to the nanomaterial? Because not all vinegars are the same. Not all vinegars are the same percentage. So that's why it would be interesting to have more.
I think also that it's a case of the Gans has been converted into a gas, because the gas that's given off would be carbon dioxide. When you mix vinegar and baking soda, that's the result. That's how they make fire extinguishers that work on carbon dioxide principle.
May I ask a question about this?
Yeah, that's why all the gas bubbles come out when he add the baking soda.
Yeah, that's what happens when you add the baking soda to vinegar. It converts into carbon dioxide. That's what's given off. So it could be that some of the CO2 Gans, which was converted into the liquid state, is now converted into the gas state.
It's also the second question is Shita?
There was a question from someone. Who was it? Was it Emmanuel? Is that you, Emmanuel?
Hello?
Yeah. Did you have a question?
Can you hear me? Yes.
This? Yeah.
Yes.
Go ahead.
Please. Is the CO3 bicarbonate structure, is it possible when it's dissolved, as you said, and turned into carbon dioxide, for the plasmatic fields of the Gans itself to reconstitute it into another into Gans after some stirring in time, because of the difference in the strength between the vinegar and the baking soda in the solution?
Okay.
Is that what's found though?
Okay, go ahead.
So what we seem to get is less material at the end of its sitting. So I would suggest some of the Gans has been gone into the air or dissolved somehow. And we're assuming that the material that we end up with is actually Gans and not sodium bicarbonate. That's because there's a lot of sodium bicarbonate that's been put into solution. Maybe that's come out of solution as well. Maybe the Gans is all gone for all we know.
Yeah.
Yeah, but don't forget also
is it possible that
on the manifestation of the Gans entities. So if you have like more compact environment in a mangrove sense point of view, the Gans adapts to this environment and shrinks itself automatically. So this is also part of explanation.
Good point.
Okay.
I have a question here. Because the sodium bicarbonate is the CO3 is bigger than CO2. Isn't it possible that the CO2 is condensed into the new CO3 type structure and has found a new type of link?
Could be, but
Livestream. Adding the vinegar into the Gans makes it disappear. Now, I've done this myself over here, but I've had a mixture of Gans. What I found was that the copper oxide got dissolved into the liquid, and the vinegar, you could smell it at the beginning, but then there was no smell after a little while. But it was interesting to see that being able to, by adding the sodium bicarbonate, that you can precipitate at least something back into the water, which is great to see. So in other words, to me, that shows going from a plasma Gans state to another state that we don't see with the Gans and the vinegar, and then going back to a matter state of some kind by seeing it in the sodium bicarbonate.
And it's interesting as well that it's a jelly-like substance gets formed. It would make sense to me that if you had a jelly-like substance with your Gans, it would have more of a buffering or more distance between the particles, more slipperiness in a way, but at the same time held in place in a way. So it could be an interesting experiment.
Does anybody remember something in the past? Keshe talked about using calcium as a way to link nano and Gans structures, because I think that the topic was how to solve together.
It's funny you brought that up, because I was just about to mention calcium, because it came up in the science news a couple of days ago, where scientists, it's actually happened about a year ago, but it's just news now. They created the fastest rotating object of all time. I think it was something like 500 or 600 million RPM, and it was a calcium carbonate molecule that they used to rotate. And they rotated that at the fastest speed that's ever been recorded. Like I say, it's over 500 million RPM. But it was a calcium carbonate, and it was a round shape, apparently. It has to be, and it has to hold together at those speeds, and that's what they found to work, apparently. So I'm not sure
Could
how.
it be deduced?
Pardon me?
Could we make a deduction to say that calcium might be a way to create more slippage and more speed of rotation, and possibly
That's what I was thinking, because
vinegar used to cause more
what
friction
it
to the nanostructure.
is a like a roller bearing, basically. It's able to rotate easily at high speeds, and that could be like a buffer, or a way of even transferring the plasmatic energies, perhaps.
Let's give a chance to Lisa to translate a little bit of this.
OK，
Yeah.
刚才呢，我们就说是主要是讨论一下这个就是生成这个东西，然后 Marko 解释的意思是说，我们有酸了以后就是改变这个环境，然后再加碱的话又改变，然后最后这个。Vince 提出了一个那个比较好的解释，他就说一个他看的这个整个的这个图画是说，一开始呢有干丝，然后你加酸了呢，就使它看不见了。然后他以前也做过这实验，但是今天呢比较新鲜，就是说你再加小苏打呢，就又生成了，就是说又是一种另外一个材料。他们都觉得说，另外这个新的材料呢比较紧密一些。就是说跟原来就是说似乎二氧化碳干丝这个不一样，也可能是物质，也可能还有新的干丝，就是等于这个磁引力场互相作用呢，也许生成新的东西了。这是一个解释。后来呢，瑞克说到，他说这个东西呢就是还有Emmanuel 说就说提到钙的问题，说钙可以在里边会有一种连接呀或者特殊的形式。然后瑞克就说他最近看见一篇报道说发现了一个就是碳酸钙的物体，这个不就是这个东西呢？可以是说到目前为止世界上转的最快的大概是1600万，就是1600万转每分钟。这个样子，然后他们又解释说，是不是这个钙呢会有这种能够可以很高速，而且会有这个光滑嘛，就比较光滑，能够转。因为什么？因为为什么？我想他们为什么谈到这个光滑性呢？因为是这两天的教学当中，他们提到过就是把干丝要分离呀，要使他们能够分层，还有一个就是说隔离，或者是要比较就是说光滑嘛，能够就是说光滑就比较滑的话，那么就互相之间层之间就会有不同的这个层之间的运动，或者形成自由等离子体，主要是考虑到这个问题，所以他们今天说了这个速度和光滑的问题。OK, I finished the translating.
Okay, just let me add that in this article, or it's actually a YouTube video, I should post the link here, but it mentions that the rotation rate is so fast that the angular acceleration at the sphere surface, that's of this calcium carbonate, is 1 billion times that of gravity on the Earth's surface. So they got 1 billion times the gravity force on that rotating sphere. And they say it's amazing that the centrifugal forces do not cause the sphere to disintegrate. And what actually happened during the experiment is that it actually disappeared during parts of the experiment while it was rotating. It just totally disappeared. So this is interesting, I think. Maybe this is one of the clues of maybe if we get the Gans to rotate rather than spinning it in a circle, but get the individual Ganses to rotate, that could be an interesting phenomenon. We'd be causing the gravitational forces with the Gans that way by rotating each individual Gans rather than all of them as a bulk ring. We need to free them up to be able to do that.
瑞克又姐说，我正还想就是提一下，就是他们做这实验的话呢，因为这个就是等于这个转的特别快嘛，快的话，这个就是说这个就是说等于这个。我不知道是球啊还是什么，就说会展示出来它的重量，也是平时的，就是这个引力的，好像也是1000倍，就说大于1000万倍的样子，然后就说从这个我们，而且就是说在实验当中会有这个粒子就是不见了的这个现象出现。然后所以他就解释，就是想说我们能不能是不是也可以转动这个干丝，就是单个的干丝，而不是说我只一堆干丝在这块大家转，是不是可以转一个干丝，就说达到什么效果？有补充吗，石头？
Okay, we are over time a little bit, so is there anything else or?
我们还
Good point.
Yeah. Next is health.
Actually,
Yeah, we can just continue.
see, 4, 3. Yes, we're okay. So yes, we can end this particular part of the workshop and carry on to the health workshop next, which we should do in a separate webinar. So,
okay.
Are we ready for that? Is that okay?
Marko?
Yeah, okay. My side,
Okay.
I don't know. Maybe other things. Do you have much more questions, or we can do it next time, or also during the health workshop?
There's more questions, but we can get that video lined up as well next time. So.
Okay, so we end here and go to the health.
I don't know. Maybe with these experiments about how to convert Gans to nanomaterial, we can do these presentations also during the Thursday workshop. So.
Okay.
Right.
Okay.
Yeah, let's carry it on there.
How are we the other issues?
Okay. 就是刚才瑞克跟 Marko 我们讨论说我们中文教学基本上时间到了，所以我们现在就是结束，然后进行下面的健康教学。然后Marko 又说我们是不是这个实验的话，到时候可以再就是说详细的做一做，然后看看就是说更深入的做，然后也可以在这个星期四的教学里面展示，就关于这个酸和碱的这个作用的视频。Okay, Rick.
Okay, so ends the 11th Chinese Knowledge Seekers Workshop. Thank you, everybody, for attending.
瑞克说这就是我们第11次中文网络教学，我们现在结束了，感谢大家的参与。